So hello guys, welcome to this full course video on pandas. In the last video, we had covered NumPy. If you guys haven't checked it out, you can go ahead and watch that video. I have provided the link in the description as well as in the I button. So before we move ahead with pandas, I want you guys to understand the basic difference or the basic requirement why we need pandas. Alright, so basically we saw in NumPy how we were able to perform various numerical as well as arithmetic operations on our arrays. That was basically a data given to us in the form of arrays, right? So why exactly do we need pandas, or what is pandas? All right, so in order to understand that, I am going to go ahead and show you guys an Excel sheet. So as you can see over here, I have some data. So once you guys get familiar with data analysis, you guys will be able to tell me that this is something known as house price prediction data set. But we need not get into the details of that right now. So for now, all you have to understand is that there are different features or different columns representing the features of a house, right? So we have the square feet, that is the area of the house. We have the city, we have the state, we have the condition, we have the waterfront, which basically is telling us whether there is a waterfront. So basically 0 and 1 is how our data is being represented. Okay, so the number of floors, the price. All right, so we have all these features in our data. All right, now if I were to represent the same thing in a NumPy array, I would have my array something like this. Okay, so say I'm just representing two houses, and these two houses have two bedrooms, two bathrooms. Okay, and the other house has just one bedroom and one bathroom. Okay, this is what my NumPy array would look like. Okay, this is basically my house 1, my house 2, and this is my bedrooms, and this is my bathrooms. Okay, so do you guys agree with me or not? Would our NumPy array look something like this or not? Except we wouldn't have this information with us. We would just have an array that would look like this. So this is the major issue that comes in NumPy when we are dealing with data. Okay, so since we only have two columns over here, maybe we can try and remember that the first one is bedrooms, the second one is bathrooms. But in case we have 12 or say 50 columns, how are we going to remember what each and every column is representing? So this is where Pandas steps in. Pandas is nothing but a tabular format of data, just how we saw in Excel. It gives us a similar representation of data in our notebook. Alright, so before we go ahead and see the demonstration with pandas, first we'll understand why pandas. So here are some of the important features that pandas provides us. So it gets very easy to import our data sets. It could be a CSV file, it could be an Excel sheet, okay? It could even be your SQL database. So you can import any sort of data set in your pandas environment. I'll be using Google Colab in this video, but you can use Anaconda or even your VS Code. Alright. Then comes your data cleaning. So this is a very important step. Now what exactly does data cleaning mean? So when we say data cleaning, we are talking about missing values and majorly the invalid values. Okay. So when we talk about missing values, okay, let me go back to my Excel sheet. Okay, so this is the data that I have, right? So say in case of this particular value over here, 10500, what if I had a blank cell over here? That would represent my missing value. Okay, so that is basically what missing value means. So if we have a particular data set and some of the values in our data set are missing, so whenever we're dealing with that kind of scenario, we will be dealing with those missing values. Okay, we will be seeing how we can do that with pandas. And the other case is invalid values. So say I have an age column. Okay, now we know our age can normally range from 0 to 100. Taking the worst case scenario over here, we have 100 or say 120. Okay, it cannot go above that and it cannot go below 0. Alright, so this is basically a standard age range. But what if I have a value say 200 in my age column? Now this is basically an invalid value, right? I cannot have an age that is 200 if it's for humans especially. Okay, so I would understand that there is some typing error or there is some mathematical error, and the common way of dealing with this invalid value would be dividing by 10, right? So 20 is a valid age, but 200 is not. Okay, so that is basically what invalid value means. Size mutability. So we can easily add and delete columns or rows. Okay, then we can reshape our data set, we can pivot our data set, we can efficiently manipulate and extract from our data set. And most important step is statistical analysis. Okay, so we can easily have all the statistical analysis of our data with just a few lines of code. Okay. Now moving on to the prerequisites to learn pandas. So you need to know any programming language, preferably Python. But if you know any other programming language as well, it's not an issue. Okay. And the next one is maths. That is basically you need to know some stats or inferential statistics. You need to have a basic idea like what is standard deviation, what is variance, what is mean, median, mode. So basically you need to have a basic idea of all those terms. So moving on to pandas, we have two primary data structures in pandas. First is series, second is data frame. Okay. Now what is data structure? Data structure is basically a collection of data types that provide the best way of organizing the items or the values in terms of memory usage. Okay. So series is going to be our one-dimensional data structure, whereas data frame is a two-dimensional data structure. Okay. Now series basically represents only a single column from the entire data set, whereas a data frame is able to represent the entire data set. Okay, that's the basic difference. So let's go ahead. Okay. So series we already discussed is one-dimensional. Why it's one-dimensional? Because a series would look something like this. So say I have a price column and these values would be represented by an index value by default. Okay, and remember our index is always and always going to start from 0. So this is our series. Okay, so over here you cannot say this is a two-dimensional or it has two columns. This is the index and this is our one and only column. Okay, so this is why series is a one-dimensional data structure, because it can accommodate only one column and you can extend it to as many rows as you want. Okay, so it is a one-dimensional labeled homogeneous array. Homogeneous array means it can accommodate only either integers or string values. Now, it's not that if I were to add, say, a string ABC, I would get an error. Rather, if I were to add a value like this, all of my integers would be converted to string. Okay, so this is why series is called a homogeneous array, because if I add a single string value into my series, all of my integers are going to be converted into string, and my data type of this series would be object. Okay. If I were to have only integers, my data type would be integers. Okay. So this is basically what it means. And very important property is it is size immutable. Now what this means is I cannot delete a particular row from here. I can only remove it, and when I perform the remove operation, basically I am going to be returned a new string. That is, my string originally is not going to get manipulated, rather I'm going to be returned a new string where my values would look something like this. Okay, so this is basically what size immutability means. And even if we try to append a new element, we would be again returning a new series rather than manipulating or rather than changing the original series itself. Okay. Now moving on to data frames. It is a two-dimensional data frame because we can have multiple columns. So we can have a price column, we can have number of bedrooms, number of bathrooms, and so on. Okay, we can have unlimited, or you can say n number of columns and n number of rows. So basically it can be extended in this direction as well as this direction, whereas series was able to extend itself only in this direction. Okay, and this is going to be a size mutable tabular structure, and it can be heterogeneous type. Heterogeneous means we can have, say, integers in this column and a string, all the string values in this column. Okay, so we can have multiple data types supported in data frames, and it is size mutable, means you're easily able to add and delete the rows and columns. Okay, so I hope the difference between series and data frame is clear. So let's go ahead and look at the implementation in our notebook. But before we do that, I hope you guys remember you are supposed to install pandas using pip install command. Let me just show you guys quickly. So you can go to your terminal or any command prompt, and all you have to do is type pip install pandas. When you run it, you're going to have a few lines of code run for you, and then finally you're going to get your requirement is satisfied, and then after that you can proceed with importing pandas as PD. Okay, so again, this is an alias. Just like we used an alias for NumPy, we are going to use one for pandas, which is PD. Okay, so I'm going to run it. And if you guys remember, I told you guys in the NumPy video that NumPy is going to be used throughout your data analysis process. So right now we are going to focus only on the pandas features, but when we come to real data sets, which I'll be showing you, I'll be importing a real data set also using a CSV or an Excel file, and then I'm going to show you how NumPy and pandas both are going to be used to perform various operations on that data set. Alright, but right now we are going to be only focusing on pandas, understand the features and the implementation. Okay, so as you can see, I have successfully imported my pandas, and the green tick over here basically represents that the operation was successful. Okay, so now what I'm going to do is I'm going to create a basic series using pd.series, and I'm going to do so using a list. Okay, now if I go ahead and print it, so you can see my data type is in64 because all of these are integers, and by default I got an index value of 0, 1, 2, 3 and 4. Okay, so as I told you, my index is always and always going to start from 0. And now if I were to add another element, say a string value ABC, you can see now my data type is object, and all of these that were integers earlier have been converted into a string form. Okay, so I am going to remove this for now because I want to show you guys some operations that we can perform in series. So I can go ahead and check the data type of my series. It's in64. Then I can go ahead and check the values of my series. Okay, so you do not need any parenthesis. So these are the values of my series data structure. So you can use s.index to check the index of your series. So you can see over here my starting value is 0 and my stop value is 5 and my step value is 1. Alright, so basically I have my index from 0 to 4. So here you can get an idea about your index as well. Okay, and lastly you have s.name. So it's not printing anything because it's none. So if I print s.name, you can see it's none because we have not given any sort of name or any sort of value to a column. Okay, in order to assign a value to our column, we can just say s.name, and we can assign a value to our column, say those are just numbers. So I'm going to write numbers, and if I print my series, you can see this is what my series is going to look like. Alright. So that was it about the random functions. Now we're going to look at an important topic called indexing. Okay, so you can do indexing using square brackets like we normally do for lists, and we have also done for NumPy arrays. So similarly you can do it for your series in pandas. So if I want the first element, I'm going to say S0 and I get the first element, that is 10. Okay, so if I want multiple elements, all I'm going to do is S0 to 2, and you can see my ending index or my ending value is not included in my output. So let me just comment it over here, and then we have the step value. So we have done this indexing in list as well, and you guys are well aware that your starting value is always included, whereas your ending value is never included. Alright, so whichever value you want at the end, you give your stop value plus 1 to your desired value you want in the end. Alright, so say I want values at index 2 and 3. My syntax for that would be S2 to 4. Okay, so as you can see over here, I got my values at index 2 and 3. Alright. Now another way to perform indexing is by using a function called iloc, which basically does location based indexing. So what this means is it is going to use the indexes, that is the 0, 1, 2, 3, 4 that you have as indexes, and it is going to fetch the values at those particular indexes for you. So all you have to do is say s.iloc and value at 3, and I print it, and you can see I got 40. So at index 3, I have value 40 and it's giving me the correct value. Okay. Now if I want multiple values, all I have to do is s.iloc and use double brackets and pass all the indexes that I want my values at. Okay. So I want value at index 1, 3 and 4. So as you can see, I got my output just as I intended. So this was all about location-based indexing. Now another important feature in series is that you can change the index according to you. Okay. So instead of 0, 1, 2, 3, 4, these numbers actually represent the calories. Okay. These are the different calories. So you can see I have changed the column name to calories. And now I want these calories to represent the fruit. Okay. So I'm going to create a list of all the fruits that are present in my carries. So you can see I've created a random list of fruits and I've stored it in the variable index. Now what I'm going to do is I'm going to say s.index and I'm going to pass my index variable. And then I'm going to print my series. So you can see over here, I am basically trying to say my apple has 10 calories, banana has 20 calories, grapes has 30 calories, and so on. Okay. So this is how you can change your indexes according to the information you are trying to represent. Now do not comment that I have put wrong calories for the wrong fruits. This is just a random data that I have created just to show you guys how indexing works. Okay. So now if I try to access any value using my indexes, so if I want to find the calorie of grapes, I can just say S grapes. Okay. In square brackets. Now can I use iloc function over here? Let's try it. Okay, so I get an error because this is not a location anymore, right? So when I had my numerical indexes, iloc was working absolutely fine. So I can still use iloc, but for my numerical indexes, right? The original indexes, that is, we have indexes in lists, we have indexes in numpy, we similarly have indexes in series as well, okay? So we can do that by iloc, but again, how will we remember what is index 3, right? So that is why we have another function called loc. This is label based indexing. Okay. So using loc, we can go ahead and say, and you can see I get my value. Okay. Now another important thing you need to remember is in label based indexing, your start as well as stop value both are included in the output. Okay. Now this is a very important thing that you need to remember because unlike normal indexing or the indexing that we do in list, numpys and all, whenever we are using a normal list, our stop value is never included. Alright. Now say I want my calories of banana, grapes and orange. Okay. So what I'm going to do over here? So you can see my banana, grapes and orange. So all three of them, that is my starting value as well as my ending value, both have been included. I hope label based indexing and location based indexing, that is your normal indexing, the difference between both of them is clear. Difference between loc and iloc is clear. Okay. So let me give you guys a quick recap. We learned how to create a series using a list. Okay. We saw the default indexes. We saw the default name, which is none of the column. Then we saw how to check the data type of the series. We saw how to check the values and the indexes of the series. Then we saw how to rename our column or the series. Okay. And then we went ahead and looked at indexing. We saw normal indexing. We saw indexing using iloc. Okay. Then we went ahead and changed the index of our series. We gave a different set of indexes to our series using s.index equal to the new index. And then we went ahead and performed indexing on our labels. That is, we used the new indexes to index the values. And then we also looked at the label based indexing, that is using loc. Okay. Now, if I want to access multiple elements over here, multiple values, again, I have to give double brackets and I can say grapes and then I want apple and I can print it. So you can see I got my desired output. Okay. So that is all about indexing. Now, let's also see how we can create a series using a dictionary. Okay. So I have already created a dictionary for you guys, which is basically fruit protein. So our keys are the fruits and our values are the proteins or the grams of protein stored in that particular fruit. Okay, so this is our dictionary. Now if I want to create a series out of this dictionary, all I have to do is say I'm going to name it S2 because this is my second series, and I'm going to say pd.series fruit protein and I'm going to print it. Okay, so you can see, and by default the name of our column over here that is representing the protein is 0. So I can go ahead and say name equal to protein. Let's run it. Now my series is giving us a complete information of what our data is representing. Okay. And you can see the data type over here is float. Okay. Again, you can go ahead and perform the similar kind of operations on this particular series. I will be sharing this notebook with you guys in the description below so you can download it and do the necessary operations that we saw in our earlier series, that is our series S. So all those operations can be performed on this particular series as well. So I want you guys to pause the video, download the notebook and perform these operations. And if you guys face any doubt, comment it in the chat box below. I will respond to you guys at the earliest possible. Okay? Alright, so I'm assuming now you guys are done with the earlier operations. Now we'll be looking at something important and something new, which is called conditional selection. Okay? Now what conditional selection basically means is, now I want to fetch all the fruits over here that have protein greater than 1. Okay? I want to find out all the proteins that are greater than 1. So what I'm going to do is, I'm going to say S2 greater than 1. Now you can see over here I've got boolean values that are representing true and false. So wherever I have protein greater than 1, I got a true. And wherever it is less than 1, I got a false. Okay? But what if I want only those rows in my output that have the value greater than 1? So what I'm going to do is I'm going to put this conditional selection statement inside my series. So I'm going to pass it inside my original series and you can see I got the result. Okay, so all these fruits have protein greater than 1. Okay, so this is basically how conditional selection works. It is first going to provide you with a mask series, which is basically a series of boolean values true and false. And if you pass that masked series into your original series using square brackets as we just did, you get your desired output. So our next topic is logical operators. Okay. Logical operators, we have and, or, and not. So I hope you guys are clear with what is and, or, not. Okay. If you guys are not, let me just give you guys a quick example. Okay. So say I have two values. One is true, the other is also true. Now if I do a and between these, if I perform an and operator between these, my result is also going to be true. Okay. Now if I have a true and a false and I perform an and operation between these two values, my result is going to be false. Okay. Similarly, if I have a false first and a true later on and I do an AND operation, my result is going to be false. And if both my values are false, my result is again going to be false. Okay. So we need both our values to be true in order to have a result true. Okay. But in case of OR, any one of our value has to be true. This is going to be true. But if I have true or false, it is again going to be true. Okay. If I have false or false, then it is going to be false. Okay. So this is basically and or. Okay. Now let's see how it is used in a series. So say I want to give a range. Okay. I want to have all my fruits, or I want to see all those fruits which are greater than 0.5 but less than 2. Okay. So all I'm going to do is S greater than 0.5 and S is less than 2. So this is the syntax that you have to follow. Okay. So you can see I got the true and false values. Now if I want to find only those rows which satisfy this condition, so you can see all these values are going to be between 0.5 and 2. Okay. I can say I can say less than or equal to 2. And now I have my fruits which have the protein value equal to 2 as well. Okay. So this is how AND is performed. So basically what happened there is wherever we had 0.5 and greater but less than 2, this range was passed to us when we use the AND operator. Okay. Now if I were to use the OR operator in this particular scenario where I'm trying to find this range, would I get this desired output? No. For the OR operator, my first condition would be greater than 0.5. So I would get all my values that are greater than 0.5. And then my second condition would be less than 2. So I would get all the values which are less than 2. That means below 0.5 as well. Alright, so as you can see over here, I have 0.3 and I have 2.6 as well in my output. So this is basically telling me that I have used an OR operation over here. Okay. So similarly, you can use and OR and you can also use your NOT operation. So I can say I want all my values which are not greater than 1. Okay. So you can see all these values are smaller than 1. Okay. So this is how the logical operators like AND, OR and NOT are performed. And then finally, we have a topic of modifying the series. Okay. So say instead of my calorie of mango to be 0.8, I want it to be 2.8. So what I'm going to do is, just like a normal list, I'm going to go ahead and say S mango and I'm going to say 2.8. Okay. So it's run successfully. Now if I print my series, you can see my mango protein has been changed to 2.8. Okay. So this is how you can modify your series. Okay. At any particular index, you can change the value. You can also change the index, but you will have to pass your entire index again. Okay. So this was all about series. Now we are going to move ahead with data frames. So I hope series was clear. If you guys have any doubt, comment your doubts in the chat box below. I will respond to you guys as quickly as possible. And do make sure that you guys have this particular notebook downloaded in your systems and you guys are working with me side by side. So that's going to make the entire process more fun. Okay. So far you guys have gotten a basic understanding of series and we have already covered NumPy. So I have a question for you guys. So basically I have a series and I want you to find the answer of this particular query. Okay, so if I say s dot not null and I say I want a sum of all the values that are not null, I want you guys to quickly comment the answer in the chat box and tell me what's going to be the answer in if we run this particular query. Okay. So moving on, let's look at our very next topic, that is data frame. So it is important and very interesting if you guys understand it carefully. So basically I have some data in the form of dictionary, as you can see over here. So I have some names, I have some ages, and I have some departments and salaries. Okay. And now I want to convert this particular. So if I print this data, it's going to look like this. Okay. It's not very neat and it's not very easy to understand. So what we're going to do is we're going to go ahead and convert it into our data frame. And let me just print the data frame for you. Okay. Alright, so I have this particular data set with me. So if I want to see just the starting values, I can just say df.head and say I want to see the first two rows. Okay, so I can do it using .head function. And if I want to see the last values, I can just say df.tail. Okay, so by default, the parameter over here is 5. But if we want, we can tailor it to our own needs. So I want to see the last three rows. So you can see 5, 4 and 3. Okay. So moving on, we can again use our loc and iloc functions just like we did with our series. So say I want to fetch the first and second row of my data set. So what I'm going to do is I'm going to say df.iloc and I'm going to say 1 to 3. Okay. So you can see I have my first and second row and all the columns. Okay. So now in case of all these columns, what if I want only department and salary in my output? So what I'm going to do is I'm going to say df.loc. So instead of iloc, I'm going to use loc and I'm going to say rows 1, 2, 3 and I'm going to say I want columns age and department. So I'm going to have a comma over here to separate the columns. So you can see over here I have age and department and my 3 rows. Okay. So we discussed earlier, whenever we use the loc function, our starting as well as ending indexes are going to be included. So I have 1, 2 and 3 rows instead of just 1 and 2. So if I want just the 2 rows, I have to say 1 and 2. Alright, so I hope this is clear. Okay, so we can use iloc and loc in this manner. But if I wanted to include my first and second column in my iloc column itself, so you can see I have my first 2 columns in my output. Okay, so basically when we're using iloc for data frames, we have to pass our rows and our columns, and the range for these are going to be separated by a column. Okay, so we can do that using iloc and loc. So we'll be using this a lot. Okay, direct indexing in a data frame gets a little complicated, so that's why we'll be only using iloc and loc functions. Okay, so you can go ahead and play around a little with iloc and loc and try to access different rows and different columns. So now we'll be moving to accessing only an individual column. Okay, now if I want to access just one particular column, all I can do is say df_age. So this is how I get only the age column. Okay, now if I want multiple columns, I have to add another bracket And I can simply separate my columns and say I want age and department. So you can see this is how I get my output. Okay. Now what if I want to drop this age column? Okay. So you can see I have a null value also over here. Now I want to drop this age column because I feel it's not very relevant to my data set. So how I can drop it is I will just say df dot drop and I will say age. Okay. And I will pass axis equal to 1 because I want this entire column to be gone. Okay. If I want a particular row to be gone, my axis would be 0. Okay. So it is a particular row wise operation. But if I want a column gone, I want my axis to be 1. Okay. So if I run it, now you can see my age has been disappeared from this particular output. But if I print my data frame, you can see the age is still there. Okay. So until and unless we use the parameter in place equal to true, by default in place is equal to false. Okay. So in place is basically telling us to perform the operation in the original data frame. Okay. So if we want the changes to be displayed in our original data frame, we are going to use in place equal to true. Otherwise, by default, it is going to be false and it is only going to return a new data frame and our original data frame is going to remain unchanged. Okay. So as you can see, it has been unchanged. Now this is a missing value over here, this and this. So we'll be dealing with these missing values later on. But first let's understand a few more functions. So we can go ahead and check the shape of our data set using df.shape. So this is telling us that we have 6 rows and 4 columns. Okay. 1, 2, 3 and 4. Okay. So again, the indexes are not counted as a part of a column, just like we did in series. Okay. So these are by default values over here. And we have 6 rows. Okay. So we basically have 6 samples. Okay. These are known as samples. This is the sample sets. Okay. So we can also go ahead and check the data type of our data frame. So we can also go ahead and check other information about our data set. So using info. Okay. So this is telling us that we have these particular columns: name, age, department and salary. Okay. And these are the data types in our column. So we have 2 columns having float data type and 2 columns having object data type. Okay. So name has object data type, age has float data type, department has again object data type and salary has float data type. Okay. Now over here we have a non-null count. Non-null count basically means that we have 6 non-null values, that is we have total 6 samples and all of these 6 samples are non-null. Okay. So basically in the name column we have 0 null values. Okay. And we move to the age column and over here we have 5 non-null values. That means we have 1 null value over here and over here also we have 1 null value. Whereas over here we have 0 null values. Okay. It is also displaying the memory usage to store this particular data set. Okay. And another operation that you can perform on your data set is describe your data set. So over here you get statistical information on your data. So over here we only have 2 data sets that are of type float or integer. Okay. So we can perform these particular operations, that is the count, mean, standard deviation, minimum value, and these 25%, 50%, 75% are basically the outliers in our data set. Okay. And the maximum value. Okay. So using the describe function, you get a basic information about your data, like you have 5 values in your age column and 5 values in your salary column that are present. Then the mean value of your age column is 28, whereas mean value of your salary column is 58400. Standard deviation is this. The minimum value of age is 25 and minimum salary is 50,000. Then you have other information about your data set. Okay. So in NumPy, we saw an important concept called broadcasting. Okay, we also looked at the rules for broadcasting. Now we'll see how broadcasting is performed in Pandas. Okay, so I have a salary feature over here. So our columns are also known as features. Okay, so these are our columns or our features. Okay, so if I want to say increase the salary of all the people over here, okay, of all these people, I want to increase the salary by say 5,000. All I have to do is say df salary and I will say df salary plus 5,000. Okay. Now you guys must be wondering, this is a scalar digit or an integer. whereas this is a one-dimensional array, right? If I just print df.salary, let me go ahead and print df salary. If I print this, you can see this is a one-dimensional array, right? This is basically an array having 5 rows and 1 column, right? And this over here is just a scalar value. Now I want to increase all these values by 5,000. So do you think if I perform this particular operation, I will get an error or will it successfully perform? So if you guys said it will successfully perform, you guys have understood broadcasting really well. So if I go ahead and print my salary now, so you can see it has been increased by 5,000. Okay. So what's happening over here is instead of treating this as a scalar value, it has been broadcasted to match the shape and size of this particular column. Okay. And then the operation has been performed over here. Cool. So moving on to the next concept, we have renaming columns. That is, we can rename the columns in our data. Okay. So if I want to rename a column, all I have to do is call df.rename and pass my columns. Okay. So I want my department column to be displayed as DEPT. Okay. And I'm going to say in place equal to true because I want this operation to be performed in my original data set itself. Okay. So if I go ahead and print my data, so you can see my department has been changed to DEPT. Okay, so this is how you can go ahead and rename your columns using dot rename function. So you can also go ahead and check the unique values in your data for a particular column. So I want to see all the unique salaries in my data set. So you can see over here, these are the unique salaries in my data set. Okay, I can check it for another column. So I can check the unique departments. So again, these are case sensitive. So if I check the unique departments in my data set, so I have 3 unique departments, that is HR, IT and finance. Okay. Now, if I want to see how many employees are in which department, I can go ahead and do the value count of these departments. So I will say DPT dot value counts. Now, as you can see over here, HR department has 3 counts, IT has 2 counts and finance has 1 count. Okay, so basically it's telling us that there are 3 people in HR team, 2 people in IT team and 1 in finance team. Okay, so this is how you can check the distribution of one particular column across your data set using value counts. Now, what if I want to create a new column called promoted salary? That is, I want to check the salary of all the employees after the promotion. Okay, so say some of my employees have been promoted and I want to create a promoted salary column in my data set itself. So if I want to do that, all I have to do is say df original salary, and after the promotion, their salary is going to be, say, multiplied by 10. Okay. So if I run this particular query and then print my data set, my data frame, so you can see the salaries have been increased in my promoted salary column. Okay. So they have been multiplied by 10. Again, this is a broadcasting rule again. Okay. So this is how you can go ahead and create a new column in your data set or your data frame. Alright, so now that we have learned how to create a new column, I think it's time to dive into data cleaning. So as you can see, we have a few null values in our data set. So I want to get rid of them because till I have those, I will not be able to perform some operations, plus it doesn't look very good. Okay. So first I'm going to check how many null values exactly I have. So all I did was I checked for my null values inside the entire data set and then I did a sum of all those values. So as you can see over here, my name column has 0 null values, my age column has 1 null value and my salary column also has 1 null value. And so does my promoted salary column. Okay. So I have a few options over here. I can either just get rid of all the rows that have these null values. Okay. So I can do that by using df.drop na. Na stands for null values. So I'm basically dropping all the null values, and if I just run this prompt, if I just run this without any sort of argument or without any sort of parameter, as you can see, I'm just left with 4 rows. Okay, so basically any row that had null value has been removed. And again, I have not used in place equal to true, so my original data set is still untouched. Okay. So this is basically just a new sort of data set that has been altered and returned so that I can see how it's going to look. All right. So by default over here, you can see my argument of how I want my null values to be deleted or dropped is any. So basically any row that has any sort of null value has been dropped. Okay. So if I run this using how equal to any, so again my result is the same. So we saw one sort of parameter in drop NA, that is how equal to any. Now the other parameter in drop NA is all. Okay. Now the other argument that drop NA takes is all. Now what this is representing over here is particular row. Okay. When we said how equal to any, we were just saying any row that had any null value. Okay. So whichever row had any null value was dropped. Now over here we are saying if all the values in a row are null, we are going to drop that row. Otherwise we are not going to touch it. Okay. So we do not have any row that has all the null values. We just have this row that has two null values. But again, we have three non-null values as well in this particular row. So again, none of my rows were altered and the data remains as it is. Okay. So this is one option when we are dealing with missing values. We can just get rid of those null values. Okay. The other way is to fill those missing values. Now how I can do that? So let me just find, okay, here is my null value, right? So I can either fill this null value with the most repeated value in this particular column. Okay, that is one option. Let me just write it down for you guys. Okay, so dealing with missing values is one of the most important aspects when it comes to a data set, because you will be dealing with a lot of unclean and messy data sets, and missing values is going to be one of them. Okay, so let me just write missing values. So one way of dealing with missing values is getting rid of them, which we just saw by using drop NA. Okay, and the next one is by filling them up. And for filling those missing values, we use the function fill NA. Okay, so this is the second method. Let us see how it works. Okay, so all I have to do is say df.fill_NA. Okay, and let me just run it. So I must specify a fill value or a method. Now I want to fill all the null values with say 0. So you can see this is what my data set is going to look like finally. Okay, but this is again a very noob method to perform on a data set, because I do not want my age to be 0 or my salary to be 0 just because it's missing, right? So instead what I can do is, for my age column, I am going to fill all my missing values with the mean. Okay, and I'm going to say, okay, let's not keep it in place equal to true, because I do not want to modify my original data. But if you guys want to, you guys are free to do it. Okay, so I'm just going to replace all my missing values in the age column with the mean of the age. Okay, so initially my third row had a missing value and now it has been replaced with the mean. Alright. Similarly, for the salary column, what I'm going to do is, if I replace it with the mean, it's not going to be very technically or mathematically correct. So instead, what I can do is, I can replace it with the median, right? I can go ahead and replace my salary in my DF column, and I'm going to say I want it to be filled with the median of my salary. So you can see over here, my fourth row was missing in my salary column, and now it has been filled with the median value. Okay, so this is another way that you can fill your missing value. Okay, now this is something that we can do mathematically, right? But what if I want to just randomly fill my value? So this was the missing value, right? So there is another method in fill NA. Instead of providing a default value, what we can do is something known as forward fill. So basically when we use fill NA, we have two methods, forward fill and backward fill. So in forward fill, what happens is we move from top to bottom, okay, and say this was our missing value. So when we use forward fill, 35 is going to be replaced in our missing value. Okay, and similarly when we do backward fill, 29 is going to be replaced for our missing value. Okay, so this is basically what forward fill and backward fill means. So let us quickly go and perform forward fill first. Dot fill na, and in our method we're just going to pass forward fill. Let's run it. So you can see 35 has been replaced in our missing value column. Okay, so it has been done using forward fill. Similarly, I can perform a backward fill. So you can see 29 has been replaced in my missing column. Okay. Now using these methods, backward fill and forward fill, can be a little tricky, and they can also give you errors in cases where your first or last value is null. Okay, so in case your first value is null and you try to do a forward fill, your first value will still remain null. Alright, and same goes for backward fill. If your last value is null and you do a backward fill, your last value will still remain null because there won't be any value before that to replace it with. Alright, so in cases like that, we go for statistical operations like mean, median, mode, alright, according to what's more technically sound. Okay, so these are some of the methods to deal with your missing values. Okay, so now we saw how we can deal with missing values. Now we'll look at another operation where we can say replace a particular value randomly. Okay, so say instead of Charlie over here, I want to replace this name with another name. So now, just because we did not use in place equal to true throughout our queries when we were dealing with our missing data, does not mean we have not already dealt with them. We have already dealt with our missing data, and currently we shouldn't have any sort of missing values in our data set. Okay, so moving on, I want to just randomly replace this particular name, say with Rose. Okay, so I want instead of Charlie, I want Rose in my name column. I just have to say df dot replace, okay, df in the name column. Okay, I have to specify the name. Sorry, I have to specify the column, and I have to say replace Charlie with Rose. Okay. So as you can see, my operation has been performed successfully. Okay. And again, if I wanted this change to be reflected in my original data set, I would have to say df name, and I would basically be storing the change in my original data set. And now I can go ahead and run it. So as you can see, I have changed the name from Charlie to Rose in my original data set as well. Okay. So this is how you can make your changes permanent. Okay. Alright, so let's look at the next concept when we're cleaning our data, that is dealing with duplicate data. Okay, so we already saw how we deal with missing values. Now we will see how we deal with duplicate values. Okay, so as you can see in this particular data set that we have over here, we have the entry Alice twice. Okay, and as you can see, the age, department salary and the promoted salary, they match for both these records. Correct? So how do we deal with duplicate values? So we already have an inbuilt duplicated function. So in order to check for all the duplicate values, all you have to do is say df.duplicated and pass it in the data frame variable. And when you run it, and your output will be your second repeated record in your data set. Right? So we are not going to consider this as duplicate. Rather, we're going to consider this as duplicate. So let's see how duplicated works. Okay, so say I have a record over here of different countries. Okay, so I have Italy, France, Greece, and then Italy again. Okay, so if I go for duplicated method, what happens is we work our way from the top itself to the bottom. Okay, so first I'm going to check for Italy. So Italy is not present. No problem. I'm going to simply add it to my list, or a list where basically I'm keeping a track whether an element is duplicate or not. Right? Then comes France. So it's not there. No problem. I add it to my list. Then we come across Greece. No problem. I add it to my list. Then I come across Italy, which is already present in my list. So therefore, this element is going to be marked as duplicate. Alright. So this is basically how the duplicated method works by default. Alright. So basically we can pass a parameter called keep, and we are going to say keep first. Okay, so let's see what happens now. So you can see our first element is not going to be marked as duplicate. So this is basically by default the parameter that duplicated takes. Okay, if I say last instead of first, you can see my first element is marked as duplicate. Okay, so when we say keep last, basically we are going to work our way from bottom to up. Okay, so that's why this element is going to be marked as duplicate. All right, so I hope this is clear. So if we want to drop this duplicate value, all I have to do is, okay, so I'm not going to pass anything because I would prefer my second record to be deleted. So I'm just going to run it. So if I print my data set, you can see my duplicated record, that was the second record, has been removed or deleted from my data set. All right. Okay. So I hope the data cleaning process is clear. We have learned how to deal with missing values as well as duplicate values. Okay. All right. So let's see how we can deal with invalid values. Okay. So since I want to make the changes in my promoted salary column, I have simply written DF and promoted salary in the brackets. And now in order to do these changes in the column of a particular data set, I will be introducing you guys to a very important topic or an important function called Lambda. So you guys must have studied this in Python as well, right? So all we have to do is promoted salary, and I will say apply Lambda x, and I'm going to say divide that x. X is nothing but the records of my column promoted salary. So this is my input variable x and this is my output variable x divided by 10. But I have a condition: if x is greater than 6,50,000, right? Else, if it is not greater than 6,50,000, I'm simply going to return x. Alright. So let me run it. Okay, so it has run successfully. I'm getting some sort of documentation, but I'm going to ignore it for now. Okay. So as you can see, the two records that I had that were greater than 6,50,000 have been divided by 10. Alright. So this is how you can deal with your invalid values using the lambda and apply function. Alright. So this is the syntax for that. So moving on, we'll also look at some string functions. So in this particular sample data set that I have taken, we do not have any sort of explicit need to do these string functions. Okay, so maximum times whenever you have a string input, okay, so say the names. Over here, I just have the first name, but in case I had a name like Alice underscore, say, Fernandez, okay. So in order to deal with inputs like this, all I would have to do was df, and I would create two separate columns saying first name and last name, okay. And then all I would do was df, and I would split my name column. So basically I'm using name as this name instead of my column name because I do not have any sort of input like this which I want to demonstrate to you guys. Okay. So even though this is not a column per se, this is just a variable that I've created, and I'm pretty sure I'm going to get an error. Okay. So I am going to split it using string dot split method. Okay. And I want to split it based on underscore. Okay, so whenever I have an underscore, I want to split my string. Okay, so in case instead of underscore all I had was a space, I could use an empty string over here. Okay, but since I have an underscore between my first string and my second string, I'm going to split it based on my underscore. Okay, and let me see if I run it, what's going to happen. Okay, so I do not have any column name, but again, this is how you would split your data set. So obviously this code is not going to run for me because I do not have any column called name, and wherever I have name, I do not have any sort of connectors between two strings. These are just single names. Alright, so I will not be able to split these particular strings over here that I have. So this is just a demo for you guys that in case you have a column like this is how you're supposed to deal with it using string.split method. Alright. So now that we are clear with data cleaning, I want to show you guys a few more examples of apply and lambda. Okay, so because there will be instances where these methods are going to be very useful because they let you change the single entries of a column or a row, right, based on particular conditions. All right, so let me create another scenario where I want to multiply the age. Okay, I want to multiply all the ages by 2. Okay, so all I'm going to do is age, and then I'm going to call my age function age column over here, and then I'm going to say I want to apply. Now instead of passing lambda, what I can do is I can go ahead and create a function where I am multiplying my age. Okay, I'm going to have my input as x, and then I'm going to simply return x into 2. Okay, so instead of calling lambda over here, what I can do is I can say multiplying age and pass x. Okay, so it will not take any input. I'm sorry about that. So let me run it. Okay, so now if I print my data frame, you can see my values of age have been multiplied by 2. Okay, so let me bring back my ages to the original value. Now this time I will use lambda instead of creating a function by default. Okay, and I'm going to say apply, and I'm going to pass lambda, and I will say x, and I will say x divide by 2. Okay, now there are no conditions, there are no if else conditions. I want all of these entries in the age column to be divided by 2, so I'm not going to pass any if else like we did previously, right? So I'm going to run it, and if I print my data frame, my ages are back to the original values. Okay, so this is how lambda and apply functions are used, and you will be using them quite a lot. Okay, so moving on, I want to tell you guys about another very important concept, that is joins and merges. Okay, now in order to understand joins, let us go through a quick overview of what are joins. Okay, so consider this scenario where I have two data sets, A and B. Okay, now when you're dealing with large data sets, it's not necessarily that you're going to have all the columns in one particular data set. Okay, so if you guys remember, I showed you guys an Excel sheet of various columns or various features of a house, right? Number of balconies, number of bedrooms, the location, the state, and so on, right? Now I had all those columns in one particular sheet. But what if I had two sheets, A and B, where in one sheet I only had, say, the features of the house, that is, the number of bedrooms, the number of bathrooms, the balconies, and in another sheet I had the different features, say when the house was built, where it's located, what's there nearby, and stuff like that. Okay, so I had two separate sheets. Now I want to combine these sheets. All right, so there are different methods. So if we talk about joins, there is left join, right join, outer join, and inner join. Okay, these are the joins that exist. And another method is to merge. Okay, merge is similar to inner join. All right, so let's quickly see what left join would look like. So if we were to combine these two data sets on, say, a particular property, and we perform a left join, our left side of the data set, okay, whatever there is common between the two data sets is going to be ignored. Whatever exists in only data set B is going to be ignored. Rather, we are going to have something that is solely available with data set A, and this happens in left join. Okay, similarly in right join it happens the opposite way. We're going to have only the properties of B in our data set. Okay, and when we perform a full outer join, we're going to have everything of A and B. Okay, so each and everything that we have in A and B is going to be included in our outer data set, sorry, outer join. And when we perform an inner join, it basically happens over here. Okay, only the common properties between A and B. And when we merge two data sets, we merge them based on this particular common column, and whatever properties A and B have, both are visible in our merged data set. Okay, so let me say this is another data set. So let me just convert it into a data frame. So I'm going to call it df2, and I will say pd dot data frame, and I will pass my department. Okay, So let me just print my other data frame. So as you can see, this is my second data set. So now if I want to combine the information from this data set and the data set that I had earlier, I have something known as concat. Okay, so concat is going to let me merge the information from both these data sets. So if I use pd.concat and pass the two data sets that I have, this is the output that I'm going to get. Okay, so since in our second data set we have a location and manager, but we do not know which employees have this location and this manager, we have a null over here. Okay, so by default both my data sets are being combined in a horizontal manner, that is they are being stacked horizontally, right? So wherever I don't have the names, I am getting null, and wherever I don't have the location and manager information, I'm getting a null. Okay, but if I were to do the same operation column wise, that is, if I were to combine these two data sets in this particular direction, I would have to say pd.concat, pass my two data sets df and df2, and I would say I want it to be joined on axis 1. So as you can see over here, wherever I have department HR, my location and manager is for the department HR, right? So this is how you can combine or merge two data sets using pd.concat. Okay, there is another function called pd.merge. Okay, so you can pass your data sets df, df2, and I want it to be merged on my column department because that is the common column. So as you can see over here, my department is being repeated twice. But if I do not want that to happen, I can use merge, and as you can see over here, my department column appears only once and my data is managed accordingly. So wherever I have HR department, I'm going to have my location as New York and manager is going to be Laura. Okay, it is, you can see it over here as well, New York and Laura. Alright, so this is also how you can merge or combine your two data sets into one. Okay. So these were basically all the operations that were there to know on data sets. The basic operations, obviously, as you go down the line, you deal with bigger data sets, your operations get more complex, but this is the standard basic base that you require to get started with pandas. Alright, so now we're going to look at how we can import a complete data set file, that is an Excel or a CSV file, in our notebook. So since I'm using a Google Colab notebook, I cannot directly pass the entire path of my file or my CSV or Excel sheet. If you're using Anaconda or VS Code, you can do that. So if you're using those platforms, all you have to do is right click on your data set and click on copy as path and create a variable and just say pd.read underscore CSV, because this is a CSV file, and all you have to do is pass the path inside the parenthesis as an argument. Alright, but since this is a virtual environment and it is not going to be able to access my local environment, what I have to do is I have to upload my data on Google Colab. Okay, so I'm simply going to select it. So as you can see, it's uploaded over here. Okay, so now all I have to do is, in quotes, I have to say data.csv. So you can see it's run successfully, and now I can do data.head. That is, I'm trying to get the first 5 rows of my data set. So you can see this is the date, price, bedrooms, bathrooms. So I can easily access all the columns, and I can go ahead and perform the basic operations, like I can check the shape of my data set using data.shape. So I have 4,600 rows and 18 columns. All right. So accessing such information in an Excel sheet would have been a much more difficult task. So this is why we use pandas, which helps us gather information like this in a much more efficient and easy manner. All right. So I can also go ahead and check the information of my data using data.info. So you can see I have 4,600 non-null values. That means I have 0 null values in my entire data set. I have 0 null values. Okay. So you can also check the data type of each and every column. Now you can see over here, this is an object data type, but date is supposed to be in a time format, right? You're supposed to be able to access the day, time, and year of a particular date in an efficient manner, but this is stored in an object manner. All right. So I'm just going to quickly show you guys how you can convert this date time from an object to a time. Okay, so this is the syntax that you have to follow. So I'm going to pass my date, and then I'm going to use pt.datetime to convert my date from object to, okay, so it is data. Okay, so as you can see, it has been executed successfully. Now if I go ahead and check my information of the data, you can see it is converted to date time format. All right, so this is how you can convert your date time features into the valid format using pandas. All right, so this is again only a one line code, but you should be aware that it can be done, and this is how you bring your data to the correct format. All right, so this was it for this video. I think we have covered almost everything there is to know about pandas, and I'm sure you guys got a basic understanding of how you guys can implement pandas on even a large data set. And I am going to give you guys this notebook link in the description, so you can go ahead and download it and practice on this data set, or you can download data sets from Kaggle. Let me show you guys the website. So you can go ahead and type Kaggle and click on the first link that you get. Register on this website and you get hundreds and thousands of data sets for absolutely free. You can download them, and you can also go ahead and check out the discussions if you face any issues or doubt, right? So get started with your pandas journey right away. If you found this video helpful, make sure you hit the like button, and thank you and see you in the next video.